All right, not such great drafting, but we have a reaction here on a pin joint here, a reaction here. These are vectors there, 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 and there. And we want to solve for the reactions, then all the internal forces. What do we need to do? All kinds of things. Realistically, if we can come up with a table knowing the radial vector to the point of application, each of the forces, this becomes even easier. But let's go through one more time how to solve for that right there. We do it by daisy chaining vectors. So we're going to go ahead and just start sliding two vectors across the page using kind of light lines there, that line there, and that line there. Now we need to take this force and slide it basically up here and then take this one down. So we're going to need to do a, if you're smart, you do it with a set of dividers, but we're not so smart. So we're going to go ahead and use our thumb. Our finger is about there. So what we do is we're going to go ahead and take our finger to there. We're going to draft our force there. We're going to take that one out. Remember what we did is we took it to the point of application. We're going to slide this one up and over. That one, well, who would have thought? It's also a finger, but the sense of how you then transfer parallel lines, you put the hypotenuse together, you slide and you lay in these forces here. So once you've got that there, it turns out that you can go ahead and take this distance here, slide it over there. Right, you didn't need to go that far, and you have the sum of these two vectors. You notice the sum of these two vectors is now here. This is the sum of these two vectors. This is not here, and this is not here. That is the sum of those two vectors. And so this one is gone, and this one is gone, and we're left with this. Double hatch means a resultant. We can go ahead and slide then a line of force along there. And it would seem to be the one that logically hooks up best with that one is this one here. So what we're going to do is go ahead and once again slide this one along. It still seems to be about a finger long. That's what a divider is for. I'll get one the next time I do this. Once again, you take out two triangles because you're now going to slide this one. What you're doing is actually sliding this one to here, so its point, its tail emits from the point of concurrency, but then you're going to go ahead and add it over here. You're going to take that same distance here, which is now, it turns out to be a thumb. And so those two forces add together like that. So this is no longer here, this went to there. This is no longer here. And in fact, this is no longer here once you do this. So that is your second resultant. If you want to put three hatches on there, just by chance, purely by chance, that third force ends up being almost at the same point there. And so once again, you've got this resultant here. This is your point of concurrency. You can go ahead and take two triangles out. Hopefully the machine isn't in the way. And even in some cases, if you're trying to do this quick, you can eye it up. You slide it over here, and you're going to take that same resultant here. Basically that distance is there, and you end up with then a final resultant that looks something like that. So those are the sum of all these forces. Your final bit then is to figure out mathematically what you want to do is you figure out the moment of the moment arm, and so you can go out and you try to figure out what this distance is. Right, the moment arm to the point of rotation. So this here is the moment arm. So you're going to take this as the moment arm. This is the resultant. And the reaction here is going to be the ratio. It's going to be the resultant times the ratio of the moment arm to the other moment arm, which of course is this full distance here. So it's the ratio of this to this, and it's going to be less because it's farther away. So the long one's going to be out there. At that point is the point you actually end up taking out a scale or a balance or whatever. You're essentially swinging circles. You take this distance compared to that distance, and you end up with your force. So we'll look at, we've got tenths here. We've also got a machine down here we could use, but we've got tenths. This is all based on ratio. You can use anything that can get you a ratio. So the ratio from here to here was around, here it is, now it's in inches. One thing you're going to be very aware of when you pick up the tape, so that's 1, 2, 3, 4, and 5. 1, 2, 3, 4, 5 inches, as opposed to 2.5. I don't know if that's quite right. Let's see. That's 2.5. So if I look at that as 1, 2, 3, 4, 5, and that one there is 2.5, can really get away from you. 1, 2.5. That would mean it is going to be half the reaction. So I'm going to do this one by hand. It is 1/2. The reaction is 1/2 of the resultant here, and then you do it again. So we're going to see how this picks up and probably do it again.